take a look at how to do a dependent t-test in SPSS. I'm going to use the same example challenge and the same data file as I did for the lecture about how to use SPSS for an independent t-test. But the challenge is going to have a bit of a twist in it. The state's really concerned about teacher job satisfaction. They're worried that if the evaluation system leads to teachers being threatened or dissatisfied, then they're going to struggle to fill positions. We still have the same 4 components for the challenge, so let's come up with a research question about job satisfaction. I know that I have data for job satisfaction at the beginning of the implementation of the new evaluation system, and I have data for job satisfaction after year 2. Kind of sounds like pre and post test data, doesn't it? So here's my research question. Did teacher job satisfaction change from before implementation to after? Remember some of the descriptors that indicated a dependent t-test? Anytime the 2 samples have some kind of relationship, or the same people are being tested or questioned twice, we do a dependent t-test. Let's go back and look at what the null hypothesis is if we're going to be using a dependent t-test. The null hypothesis states that the change, that symbol is a small delta, it stands for change. The change from pre to post or from beginning to end is going to equal the mean from the beginning group or the beginning sample minus the mean for the ending sample, and that's going to be 0. In other words, our null hypothesis is saying there's going to be no change pre to post or from beginning to end. So what am I looking for? I'm looking for a test statistic that is larger than the critical value for the test statistic that I could set with that degree of freedom. In other words, if my probability is less than the significance level I set, I can reject this null hypothesis and confidently say there's a difference, there's a change between pre and post. But if my probability is greater than the significance level I set, I have to keep the null hypothesis that the pre and the post are the same, that there's no change. So now we're ready to look at SPSS. Okay, I'm going to show you how to run a dependent t-test in SPSS. We're going to open up the same data file that we're using before, and this time in this dependent t-test, we're concerned about their beginning job satisfaction and their end job satisfaction. Notice that for each teacher, we have 2 survey results. We've got their beginning and their end. Those are paired samples or dependent samples. So we go up to Analyze. Again, we're comparing the means on those 2. And SPSS calls it a paired samples t-test instead of a dependent samples t-test. And the dialog pops open like this. Now let's look at what we've got here. It wants us to identify the pair. So I come down here to beginning job satisfaction. That's the first of my pair. And end job satisfaction is the second one. Options is still where I can check and make sure that my confidence interval is still set for 95%. And that's all there is to it. I click OK and let SPSS do its work. Now, I like to label my output so that I always know what I'm working with here. So I'm going to call it my dependent t-test, and this is beginning and ending job satisfaction. There we go. So now let's look at what we've got here. First of all, we've got the statistics and the information about what those 2 responses were. For the beginning job satisfaction survey, the mean was 5.36, the standard deviation was 1.85, and for the ending, the mean is 6.44 and the standard deviation is 1.71. Notice that my N is 25 for both of them because I had 25 teachers answering this survey both times. SPSS also gives me the correlation, and you would expect a correlation at least this high between paired sets like this because their ending job satisfaction response is going to be related to their beginning job satisfaction response. Quite high, you would expect that. Now let's look at our t-test down here. This is where we get our information. Notice that there's no test about homogeneity of variance. We are using the same people, so we don't have to test and see whether we should use the assumption or we can't assume that there's homogeneity of variance here. This gives me the difference in the means, so the difference between these means. And then I come over here and here's my t statistic right here, a negative 4.301 standard deviations. And my significance is very low. In other words, this test statistic is so unlikely just by pulling random samples out of the population. I wouldn't have got this difference in the means just by randomly pulling them out. The probability of that is very, very, very low. So I'm going to reject my null hypothesis. This t statistic is much larger or much smaller, think absolute value, than what the critical value would have been if I had done this by hand. Now you've got another piece of information right here. Remember I told you that if there's no zero within this interval, that's more evidence that this difference over here, this difference between these means, is statistically significant. And that's all there is to it. Let's go back to the original assignment or the challenge that was given. First, I was asked to come up with a research question, which I did. Next, I need to describe the rationale behind the analytical approach I took. I need a statement about why I did a dependent t-test. I need to make it really clear that there was a relationship between the data in sample 1, the pre-survey, and the data in sample 2, the post-survey. So I would write something like the beginning job satisfaction and ending job satisfaction rating for each teacher come from dependent samples. Therefore, a dependent t-test was done. So now I need to report the results. For this, I'm going to go to my output from SPSS. I'm going to zoom in a bit, but hopefully you have your output to look at and make notes on if you've been following along and doing what I've been doing in SPSS. First of all, we have the means for the beginning survey and the ending survey, so I report that first. The mean for the job satisfaction survey before implementation was 5.36, standard deviation 1.85. The mean for the job satisfaction survey after 2 years of implementation was 6.44, standard deviation 1.71. Next, I look at the results of my dependent t-test. I can report the change between the two means was statistically significant. That probability, significance two-tailed over there, is below 0.05, which was my significance level. So I write that up. The change in the mean for the job satisfaction survey before and after implementation was 1.08 points. This change was statistically significant. T, 24 degrees of freedom, equals negative 4.30, P less than 0.001. Let me point out something. The change in mean was figured by SPSS as sample 1, or beginning, minus sample 2, the end, because that's how it was set up in my null hypothesis. This is an example of where you need to be paying attention to what your data mean. The average after implementation was higher than the average before implementation. So the difference is a negative number when I take sample 1 minus sample 2. But that would not make any sense to report. The change was, in absolute value, it was a change of 1.08 points. So I report it that way as an absolute value of the difference in the means. Because now I have to interpret or summarize what I found. So I would tell my audience, comparison of the before implementation survey and the after implementation survey shows that teacher job satisfaction actually increased after the new evaluation system had been in place for 2 years. And now you're ready to try it.